Hi Chem Peeps. In this video we're going to talk about intermolecular forces. There's three that I'm going to focus on: the dipole-dipole, the hydrogen bonding, and the London dispersion. In video 2 I will do sample problems and applying these intermolecular forces, so please look for that video to come. Intermolecular forces are not bonds. We talked about bonding in another video where we have covalent bond between nonmetals and nonmetals where they share electrons, and we talked about ionic bonding between metals and nonmetals where they form a crystal lattice and there's a transfer of electron from the cation to the anion. Those are within the compound. With intermolecular forces, we're talking about forces of attraction that occur between compounds. And so that can be in a pure compound, like say, for example, water, or it can even be like water with sugar dissolved in it. And it can be between the water and the sugar in that solution. So let's just define what the three intermolecular forces are and where we would typically find them. In the second video, we'll do some examples. So dipole-dipole is when you have opposite charges, or what we call poles, of different molecules attracting. So here we have hydrogen sulfide, we have hydrogen and sulfur, and you can see within the molecule itself we have partial charges, not full-blown charges, but partial charges. And that occurs because the sharing of the electrons between the sulfur and the hydrogen are not equal. This would actually be a polar covalent molecule, and so there is a positive side and a negative side that is partially charged. Well, when another molecule comes along and it has a partially positive charge, that partially positive charge attracts to that partially negative charge, and likewise the negative portion of that will attract to the positive of another one. And so there's an attraction there between the different partial poles of the molecules. The one below is hydrogen bonding, and this one is very specific. What do I mean by that? Well, it must have hydrogen in one molecule and a fluorine, oxygen, or nitrogen in another molecule. And why is it so specific? Well, it just so happens that these small atoms of fluorine, oxygen, and nitrogen, and the small atom of hydrogen creates a huge electronegative difference within the molecule, and it makes it very strong between molecules. So here we see water. Water is the classic example of hydrogen bonding. We have the partially positive side of water, the partially negative side of water, and it attracts with hydrogen bonding to the next molecule. So the partially negative attracts to the partially positive. But because these molecules, or these atoms, are so tiny and so electronegative, this hydrogen bonding that occurs is exceptionally more strong than the dipole-dipole attraction. And so we find some very unique properties and behaviors of molecules that have hydrogen bonding, and we'll see that in video 2. So in the first two examples, we've been talking about partial poles. What if a molecule is nonpolar? Because we see that example in nonpolar covalent molecules. How do they attract to one another? Well, remember, even though they're nonpolar molecules, we still have protons and electrons in the atoms. And there's a shifting or a movement of those protons and electrons so that there's temporary poles. Okay, they're not more permanent like the polar molecules. So temporary poles where they attract to one another, and they kind of like flux together. So you can see here, this might be partially positive here, and this is partially positive, partially negative, partially negative. Well, that will shift. It doesn't stay that way. The protons and electrons are constantly moving, and so we have this temporary pole. This is the weakest attraction, but it still exists. So this is the weakest, this is the strongest, hydrogen bonding, and dipole-dipole is in the middle. Okay, and so find me on my next video where I use applications of these concepts in sample problems. You can find me on TikTok and YouTube at Chem's Chem Chat. Leave a comment if this helped, and I'll talk to you later.